Hello, fellow stackers. Thank you for joining us here today. I'm very excited to be able to put together this very brief demo that's around one of our newest features that's included in Rackspace Private Cloud built on OpenStack version 12.2. And that feature is a load balancing as a service feature. We wanted to be able to take the time to kind of walk you through how to be able to set up that feature on your OpenStack cloud, as well as how to validate it once it's running. And then execute two different types of possible use cases for this load balancing as a service capability. One thing to keep in mind is that here at Rackspace, we actually use the OpenStack Ansible project to be able to deploy private clouds. So what I have here is a very small lab environment that's running Rackspace Private Cloud version 12.2. And if you're running OSA, it's version 12.1. Whatever the latest tag is that's out there on GitHub. I want to step you through what needs to be set up to be able to configure this service, as well as how to validate it once it's installed. And then we're going to move into those two possible use cases of how you can leverage that load balancing capability within your clouds. So if you're ready, I would love to get started. So what I have up here on the command window is I'm already connected to my all-in-one OpenStack server. I use it as all-in-one just to keep things simple. OpenStack Ansible was actually deployed from this server. So all the configuration files for that are actually on here already. So what we're going to do is we're going to move into the directory where we have those files present. And we're going to take a look at a file called user variables. And what makes a user variables file so special is that is a place where you can configure all your custom variables that you would like to apply to your OpenStack deployment. And for this particular feature, the load balancing as a function feature, you need to be able to add in this variable here called neutron plugin base and be able to supply these three different types of plugins to be included. And by enabling these three plugins, particularly the last one, you're then going to basically enable that load balancing as a service capability that is controlled by and managed by Neutron. So that's the first piece of the puzzle. Inside of user variables, you need to be able to add this block there. And that's going to basically tell Neutron when it goes to install and configure itself to include the load balancing as a service plugin. So now if we can take a look at that, we can now move into, so imagine, because of timing, we're not going to actually step through deploying the OpenStack cloud all here through this demo. So imagine you've already deployed your cloud and you're ready to go and you want to validate that the load balancing as a service capability is present. So what we're going to do here is we're going to execute a very simple LXC command, just keeping in mind that all the OpenStack services and OpenStack Ansible are installed in two separate LXC containers. So what I need to do is I want to pop into the LXC container that is actually running the Neutron agents. So I'm just going to basically grab the IP of that guy and we're going to SSH right into that container. So now we're inside of the Neutron agent container. And we want to move into the directory where we have all the Neutron configuration files. And what we want to do is we want to take a look at the file that's relevant here, which is the LBaaS agent.ini file. And when you see that file is present, that's a very good sign that your load balancing capability is actually turned on within your cloud. So we're just going to take a quick look into this file, and what you'll see here is this is a very high level configuration for your LBaaS feature. Paying particular attention to the device driver, we are using version 2 of the load balancing API, but we're not leveraging Octavia at this point. We're actually leveraging the agent, which is backed by HA proxy, so that's something to keep in mind. So now that we see that this ini file is there, we're getting closer to being able to determine if things are running good. So what we're going to do next is we're going to jump into the next container, which is the utility container. And if you're not familiar with what the utility container is inside of OpenStack Ansible, that's basically a container that has all of the Python CLIs already installed. So this is your place where you can do all your administration from and have everything at your fingertips within your cloud. So first thing I'm going to do is I'm obviously going to source my OpenRC file so that I can pass all my credentials and store that ahead of time. And the next thing I'm going to do is I'm going to execute a simple neutron command that's going to do an agent list. And what this does is this allows me to list out all the agents that are running in my OpenStack cloud. And this is one very easy and quick way to validate whether or not a load balancing agent is up and running and available. So we can see that by executing that command, that agent is available. We have a nice smiley face, which means it's alive, and yes, it is enabled true. So from a very high level, it looks like we're good to go as far as LBaaS is concerned. So since we've gotten past that part, let's move on to working through our first use case around the LBaaS. So the first use case is a very simple one. We basically created a heat or a heat template, a hot template, as some people, or hot heat orchestration template, to be able to demonstrate some of those LBaaS capabilities. It's very simple. It's going to launch 2 instances, and it's basically going to attach those instances as pool members to a pool that we're going to create. And of course, subsequent to all of that, we're actually going to create a load balancer and as well, obviously a listener for that pool to be able to attach to. And we're going to do all that within inside of one heat template. So since we're already in the utility container, we're going to jump into a directory that I have here. And basically these are some heat templates that I pulled down from a Git repository, my personal Git repository, where I've stored some of these templates ahead of time. Now that we're in the directory where we have those heat templates, I'm going to do a very quick directory listing, and you'll see I have quite a few sample heat templates going there. But the ones we're gonna execute in this particular occasion is the add VM to VIP heat template, and let's give that a go and let's see how it works out for us. Okay, so we're gonna execute that heat template there, and while that goes, what we're going to do is we're going to also log into Horizon dashboard. One little negative to the LBaaS version 2 endpoint is that the Horizon panel is not available for it, so you can't really see what's going on inside of LBaaS and Horizon with the current time, but future releases, obviously that panel will be added to Horizon so that you can manage LBaaS within Horizon. So we just very quickly will pop into our stacks that we have running, and that test LBaaS stack that I executed below has completed. And if you take a look at just here, and we didn't really be able to catch the dynamic when the heat template is built and how these little dynamic things kind of pop around and turn green when they're ready. But we can see there's quite a few items that are here that is actually making up this heat template. And just kind of popping in and taking a look at some of the resources we leveraged and some of the things we created. So obviously we created our load balancer, we created our VIP, we created a VIP pool, we added the members, as well as we created our servers, as well as we attached those servers so that they can have floating IPs. So these servers are attached to 2 networks at the same time, a private and a public network. And I try to make this as close of a use case as possible as to how you would actually configure this if you were going to do this in your cloud. So we can very quickly see that the 2 instances that were supposed to be created in a heat template are up and running, and they're here. They have their 2 IP addresses and they're ready to go. So if we jump back into our command window and execute an OpenStack server list command, it is just going to bring back a list of all the servers that we have available in our cloud. But now we're going to execute some neutron commands to be able to validate whether or not our load balancing as a service capability is actually working, and that our heat template actually did what it was supposed to do. So the very first command we're going to do here is a neutron LBaaS load balancer list, and this is basically going to list out all the load balancers that are available. The next one we're going to do is a listener list, which will obviously do what you think it is, which is show all the listeners that are available. And the next one we're going to do is we're going to do a pool list. So we're going to list out all the pools that are available that were created just recently with that heat template. So we can see we have our load balancer that was created and active. We have our listener, which is created running on port protocol HTTP port 80, and that's also active and ready. And last but not least, our pool is also ready to go. The last piece of the puzzle is what we're going to do is we're going to take that pool member ID and we're going to execute one last command that's going to actually show us the pool members that are part of that pool, because that's a key thing to check on, is making sure that the members that you told it to add to the pool were actually added. And this is one way we can validate that. So once we do that, it actually shows us the two instances that are attached to the pool, and they are associated with IDs. And what we can do is very quickly correspond the addresses that are associated with those two instances there, directly relate back to the instances that we have created up here. So 114 and 115 are IP's addresses. And again, running on port 80 and have an equal weight and are ready to go. So this was a very simple example of how you can use the heat template to be able to spin up instances, create a load balancer, create a listener, create the pool, and then attach those instances to that pool as members.